Welcome to the first lecture of the MOOC course on design and analysis of experiments. In first half an hour of time, I will try to cover the following topics. First, we will define experiment with certain examples. Then experiments in terms of process models, where we will try to link with laboratory as well as industry based experiments. We will find out the key terminologies related to design and analysis of experiments. What are the different objectives of conducting experiments and analyzing the data pertaining to the experiments, and a few case examples where DOE can be used and how DOE will help in achieving the objectives, and then a brief history of the DOE. I hope that within half an hour we will be able to cover this. The lecture material is prepared primarily based on the book entitled Design and Analysis of Experiments by D.C. Montgomery, which is published by Wiley, and I follow the contents of chapter 1, and it is of the 8th edition of this book. And in fact, my subsequent lectures also will be heavily drawn upon this book written by Montgomery. So, let us first know that what is experiment. Before giving the formal definition, let me give one example. Suppose you are tossing a coin, then you will find out that after first trial you will either get head or tail. If you repeat this second time, again you may get head or tail, and you can continue in this manner. This is an experiment because there are certain outcomes. In this example, head or tail will be the outcome, and there is definite purpose of that toss also. Maybe you are in case of cricket, you have seen that the toss is the first thing to happen, and the captain who win the toss, he will basically choose either head or tail, and after the umpire or the referee he tosses this. So, either one of the captain will win, and the purpose is that captain will be able to choose whether go for batting or fielding first. So, these things, if we think analogously we will bring it to a production system, then you will find out that there are operators and there is a system is given to him or her, and the production system produces something, and there are certain quality of the output to be produced, and accordingly there is a set of process variables that to be controlled, and the operator what he will do, he will fix the process variable to the desired or the given range as per the specifications. and then ultimately process is run. So, now you think that you have the operator has the capability as well as he has the authority to do some kind of manipulation in the input as well as the process variables, the output, so that the output can be changed and purposefully changed, and in order to see the effect of those process variables in the output quality, then it is also an experiment. Similarly, in the laboratory, suppose in chemical laboratory or chemistry laboratory, you will find out that suppose you are mixing maybe your acid and base to produce some salt, and then by changing the quantity of the material, acid or base material, you will find out different kind of quality of the output. So, even you will find out in the sociology side also. Suppose someone is interested to observe the behavior of a certain system, for example, maybe the behavior of the traffic or maybe behavior of some animals. So, there also some stimulus or stimuli can be generated in such a manner that the subject, here it may be the animal, will perform based on the stimuli given. The performance or the behavior will be may be different for different stimuli. So, purposefully if you control the stimulus side, what will happen, the output also be controlled. So, these are also experiments. So, given these examples, so I want to read out the formal definition of experiment. An experiment is a test or series of tests in which purposeful changes are made to the input variables of a process or system, so that we may observe and identify the reasons for changes in the output response. So, experimentation plays an important role in technology commercialization and product realization. For example, the laboratory based experiments or prototype typing based experiments or large scale field based experiments also. These things are done in order to have good product, in order to produce good product, in order to design product in such a manner that the defect during production will be minimized. Similarly, in case of manufacturing process development, because if you produce something in item or component or the product as a whole, it will be produced through a manufacturing process, and that process design itself is also very important one, because the process variables will ultimately affect the product quality. So, how to develop a manufacturing process so that the product that will be produced will conform to the specification. So, the specification which are derived based on the customer requirements, may be through a broad customer survey or market research. Sometimes what happened, you are producing something with a given process, you want to improve the process, maybe in terms of extension or in terms of existing process performance improvement. So, in that case also the experiments can be conducted and the resultant data can be analyzed in order to find out the avenues for process improvement. So, as I told the process is a very important one. Now, for this particular subject DOE, design and analysis of experiments, I will use the abbreviation DOE. So, in DOE the definition of process is not the manufacturing process alone. Here we will define process a more generic way, more general sense. Here a process is something where some transformation will take place on to the inputs, and as a result some value added outputs will be produced. For example, I told you that in a suppose you are manufacturing some maybe steel you are manufacturing, or you are manufacturing some engine wheel rim maybe. So, that means what you require, you fed raw materials with certain other components to the process where some chemical and physicochemical changes takes place, and then ultimately either the wheel rim or the your molten metal in case of steel making, this will be the output. This is one kind of manufacturing example. Another kind of example may be that patients going to hospital, and they will go through a process, some steps, like you can say that starting from the appointment to consulting the doctor, to test, then finally give medication, and then ultimately the patient will be cured and he or she may be admitted to hospital. So, there in the medication process also there are certain steps. In another way, suppose you are writing a program which will give you some output, suppose a prediction model you are developing. So, then in the program, the algorithm you are building, there are certain steps which will be executed, then only the prediction model will give you the desired output. So, that means a process means a series of steps, either these are chemical, mechanical, electrical, or your service related like healthcare, or it is algorithm, whatever may be. There are certain steps which are taking place, and these steps are taken on the inputs, and some outputs are produced. So, the process itself has certain characteristics. These characteristics are named as controllable factors and uncontrollable factors. For example, if you are producing suppose wheel rim, and through a centrifugal casting process, then the speed of the process, the feed rate, and the molten metal flow, all those things will be the controllable factors. And there will be certain factors which you may not be able to control, maybe the ambient temperature during cooling. After casting you go for cooling, that may not be controllable. So, similarly, the operator who are coming from different background and having different qualification, different training level, they may not be controlled. So, in that sense, whenever you do any kind of production or any kind of service operation, there are many parties involved. One is the process itself, which is having two kinds of factors, controllable, uncontrollable, as I gave in examples. So, the sole purpose of this process is to produce something, or to either you perform some operation, or you give some service, or you produce something, and that what you are performing and what service you are giving or what you are producing, all those things will be tested with certain characteristics. This is known as response of the process, or in quality terminology known as quality variables. The product will have good quality, the service should be of good quality, the performance will be of the satisfactory in nature. So, now DOE is applicable, or you do experiment here in how now you manipulate the controllable factors and also sometimes inputs in such a manner that the output quality or the response here that will be at the desired level, or the variability of the output will be at the desired range, or you want to know the relationship between the output as well as the controllable factors, or also sometimes the noise factors. So, that means you do experiment in order to achieve something what is written in the left side of this slide. You may be interested to know what are the most influential x variables for y, means the contribution of which of the x variables is more on y. You may be interested to know where to set the x or the most influential x such that y value, the response or y will be always at the desired level or the nominal level or at the nominal value. Similarly, you may be interested to control the x in such a manner that the y variability will be minimized, or although z, the uncontrollable factors are not being controlled during experiment, because you are not able to control it, or it cannot be controlled because of the cost point of view. So, in that case, is there any opportunity to manipulate the x in such a manner that the z effect on y will be minimized? So, that is what is the purpose of experiment. What are the purpose of experiment? At the first hand, you please understand, the experiment is done on a process. What is a process? A process is something which takes the inputs and converted into evaluated outputs, and process is governed by two kinds of factors, controllable and uncontrollable factors. So, the experiment, use of experiment, the objective of experiment is to know four things. One is determine the most influential variable, that is x, on the response of y. Set the most influential x in some value or some range, so that the y will be always at the nominal value. Other hand also, you set the controllable factor x in such a manner that y variability will be minimum. So, minimize the effect of z variable or uncontrollable variable on the output y. So, I want to extend it little bit. I want to write something here. How to write? Anyhow, so let us move further, because there are some more important. So, let us assume that the output variable is denoted by y, x denote the controllable factors, z denote the noise or uncontrollable factors, and y is the output. The experiment is done to find out y, what is the functional relationship between y, x and z. So, this can be told as y is function of x and z. So, when you do the experiment, you get results of y, x, y and x. Z is uncontrollable, you cannot manipulate, so that you will not get. So, essentially what happened, sometimes you may able to manipulate z also, but that is very costly, as I told you, but for most of the time, that means x you will control. So, if this is the relationship, Then from variability point of view, you can write that the variability of y is delta y, and if variability of f x is delta x and variability of z is delta z, then this kind of relationship can be written that you have seen. So, delta y will be del f by del x into delta x plus del f by del z into delta z. Delta y is the change in y, delta x is the change in x, and delta z is the change in z. What is del f by del x? It is basically the coefficient, the relationship coefficient. If you change del x by delta x, what will be the change in y? That will be finally weighted by del f by del x. Similarly, for del f by del z. From this equation, we can give some terminology of DOE here. Suppose you are interested to know what is this, y is a function of x z, or sometimes y is a function of x, like y is a linear relation beta 0 plus beta 1 x 1 plus beta 2 x 2 plus error. So, this is a linear relationship also you may be interested to develop. This is nothing but y is function of x. Similarly, it may be nonlinear, okay. But you want to know this, you want to establish this, then this is, once you establish this is known as process characterization. So, what is process characterization? Process characterization, knowing the relationship between y, x and z. To know about the input variable x and uncontrollable variable z, controllable x, uncontrollable z, that will affect the output variable. So, y is function of x and z. As I told you earlier, most of the time this z will not be included in the function. Second one is the delta x. Where to set delta x? So that the y will always be at the desired level. So, what does it mean by desired level? Suppose I know that my y variability is like this. This is a normal curve and the mean value is here. This is the desired value, nominal value. So, I say that this y, this is the nominal value or the desired value. This value is also controlled by x or affected by x. So, where to put this delta x so that y will be always here? It will not be always here, but it will be around approximately within this. So, this is known as process characterization, process control. Y is f x z, process characterization. Where to set delta x so that y will be at the nominal value, that is process control. Then you have seen the another component is del f by this one, del f by del x. So, to capture the changes of x, that is del f by del x, so that the value of y is minimized. So, you want to minimize the variability of y, not value. This is variability of y is minimized. This is known as process optimization. Another one is very important one equally, that you know that z cannot be controlled during experiment and z is uncontrolled variable, but there may be relationship between x and z. So, if you encash this relationship and accordingly you set x in such a manner that the z effect will be nullified. So, if we put delta y equal to 0 in the equation, that delta y equal to del f by del x delta x plus del f by del z delta z in this equation, if we put this one equal to 0, then you will get this. The beauty of this equation is mean that if you change x, if you manipulate x in such a manner that that ultimately the variability of y can be further minimized, and the effect of uncontrollable or noise variables, that will also be nullified. So, if not completely nullified, it can be minimized. So, this is known as robust design. With reference to process characterization, process control, process optimization and robust design, I will give you some of the examples here. First example is a flow solder machine is used in the manufacturing process for printed circuit boards. The process engineer would like to conduct a designed experiment to determine which controllable variable is significantly affecting the output quality, and also to find out the ways to reduce the variability of output due to change in the uncontrollable variables. Then what is required? This is a solder machine, flow solder machine. So, this is the process is this one. Now the solder machine is the process. It has set of controllable factors. We have enlisted the controllable factors: solder temperature, preheat temperature, conveyor speed, flux type, flux specific gravity, solder web depth, conveyor angle, etc. And it also has certain uncontrollable factors like thickness of the printed circuit board, types of component used, layout of these, operator, production rate, etc. So, if you want to do experiment, your first thing is that you must know the system. Here is the solder machine and how the solder machine will work under this situation when manufacturing of process printed circuit boards, and what are the inputs and what are the outputs. So, what are the controllable factors and uncontrollable factors. Here I have committed one mistake here, that defect also I have written solder defect, is not correct. So, what happened, the printed circuit board should have less soldering defects, that is the purpose. So, once you do this, then these are the factors, you want to control these factors in such a manner that the defect will be reduced or minimized. My second example is, here suppose consider a chemical process and you want to improve the yield of the chemical process, and it was found that from the experts that the two important variables are reaction time and operating temperature. So, you want to conduct an experiment in such a manner that you will know that how reaction time and operating temperature will affect the yield. So, in the right hand side we have shown that this axis is x1, which is reaction time, and this is x2, which is operating temperature, and the reaction time from 80 minutes to 90 minutes, and your operating temperature 170 degree Fahrenheit to 180 degree Fahrenheit, this range. Suppose you have considered this range, this is the range of operating zone that is of interest. And then you created several settings here, that first this one, second this one, third this one, fourth this one, and also this is another one. But these 4, 1, 2, 3, 4, these are at the corners. These are known as basically factorial points that we will discuss later on. But for the time being, you understand that you will be interested to know how the process yield, that is y, that will be affected by x1 and x2, and you want to know what is this function x1 and x2, then process characterization. If you want to say no, suppose I want to set x1 and x2 in such a manner that variability of y will be minimized, that will be your process control. If you say I want to see that that the influence of x1 and x2 trap that coefficient in such a manner that this will be minimized, then it will be your process optimization. So, you may be interested that there are some other variables which is not considered here, they may be acting as a noise variables. So, that their effect can be what I can say partial out. So, in that case you may go for a robust design. My third example is a biomedical engineer wants to design a new pump for the intravenous delivery of a drug by varying the controllable factors which are already mentioned here, and want to investigate which factors are the most influential on pump performance. So, there are 8 controllable factors identified: diameter of the cylinder, length of the cylinder, feet between the cylinder and the plunger, the length of the plunger, diameter of the tube, the wall thickness of the tube, the material to be used in fabrication, the nominal pressure, and this pump performance, basically new intravenous delivery. So, what we want basically may be either the length of cylinder or diameter of the cylinder or feet between the these things, the feet between cylinder and plunger. So, they will be manipulated to just see that how best the pump will operate. Fourth example here is maybe in the case of designing a aircraft engine. So, here what happened that the response and quality or the quality variable of interest are your fuel consumption and engine thrust. So, these are the controllable factors. So, you want to design an experiment in such a manner that you will be able to do those things what we have already you are able to achieve the objectives like starting from process characterization to robust control, robust design. So, here what happened actually the engineer is interested to use a computer model. It is not that in the laboratory all the real production stuff he will be doing the experiment, he will be using a computer model, and their computer based experiments will be developed. Okay. So, if we consider the three factors, usually this kind of cubic diagram we will use, and later on I will extensively see that from your rectangle to cuboid to the higher level that geometric will be using. Okay. Then in the another example here, suppose a biochemist is formulating a diagnostic product to detect the presence of certain disease. The product is a mixture of biological materials and chemical reagents and other materials. So, your work is basically you want to see that how these three materials will be mixed, so that the performance of the drug will be maximum in curing the disease. So, in that case this kind of design we will adopt. So, here you see that x1, x2, x3, that three material which will be mixed, and this is known as mixture design, and there is a good example and good literature available on mixture design, which is also coming under experimental design. So, with these examples as well as what I have discussed so far, so you must know that you must be able to or I can say that define an experiment, and you must be able to identify your problem in terms of a process model, And when you find the process, you must know that in a process there will be output variable which are known as response variable or quality variables if you are thinking in terms of quality. More generic name is response variable which we denote by y, that is y. There will be inputs, there will be x and there will be x, z input. So you, this is what is the process. So you must be able to, based on your system or the problem at hand, you will be able to find out this. Unless you are finding out this one, then you cannot go further. So once you know the response variable and what is the objective you want to achieve in terms of response variable given x and z and input, then your work comes that how to set the controllable factors, at what will be the settings of different factors, what will be the different labels of x, and then how do you do the experiment, and all those things will come. Primarily in this lecture I talk to you about experiment, I talk to you about process model, then we say that y can be a function of x and z, and we also have seen this equation delta y equal to this, you have already seen. So your process characterization, process control, process optimization and robust design, those the concepts described here. So all those things are done with the help of designed experiments. But if you see the history of designed experiment, it is not that one day development, it is a great history, and it started in the agricultural origin in 1918 by R.A. Fisher and his co-workers, primarily how to improve the yield from the agricultural land, and that era is 1918 to 1940. And there are a lot of what I can say significant impact of this designed experiment on the performance, particularly in the yield of agricultural fields. And then that time factorial design and analysis of variance, these things were extensively used, and these many concepts were developed. Then after that the other pioneers are Box and Wilson. Actually in this period 1951 to late 70s they worked a lot, and that means that from agricultural region to the industrial sector it has been basically translated there, and but primarily chemical and process industries are heavily benefited out of these designed experiments and analysis of the experimental results. And in Box and Wilson they are one of the theoretical contribution is the response surface, and that response surface will be we will be knowing also response surface in some of the lectures. You will also know factorial design, you will be knowing analysis of variance and how to do different kind of analysis using analysis of variance, that also will be known to you. Then came to this quality engineering era, which is basically primarily because of Taguchi, that quality improvement initiative, and Taguchi's robust design, robust parameter design, and he also given the concept of process robustness from product robustness. That time you will see that the many other quality gurus were there, Deming, then your Juran, then your Crosby, Feigenbaum, then that Taguchi and all, but they have different contribution in different era. Particularly in this era, Taguchi, that quality improvement, all the techniques by Deming, Juran, Crosby, Feigenbaum, and Taguchi's robust parameter design. Mainly Taguchi coined the word that quality engineering, and DOE plays huge role in the quality engineering domain. And Taguchi developed Taguchi given different kind of orthogonal arrays and their use. And then the present day, that is the modern era 1990 onwards. Now what happened, that lot of data are not only from experiment, from other sectors also data is coming. Now data analytics is a boom, and in fact DOE data, this kind of data are also used because data coming from different sources. And we will see later on that mean model, then variance model, there will be joint model like mean variance model, and there are a lot of application of multivariate statistical models and new developed techniques that we will see slowly. But this subject is this is basically a design and analysis of experiment. This subject is design analysis experiment, so it is a basic subject. All the fundamentals of experimental design and analysis will be taught to you, and some detailed calculation will be given to you. Different small examples will be given to you, and there will be hands-on tutorials for you. So I'm hopeful. I'm quite hopeful that you all will be enjoying this subject, and you will be learning this, because you know the data will come, design data will come from different sources also. In laboratory, scientists are developing, in field engineers are doing it, even the managers are also experimenting every day. So it has huge application, and there are very good techniques also for doing this work will be taught to you. So with this I finish this first lecture, but at the end I must tell you that this is the book Design Analysis of Experiment by Montgomery. This is an excellent book. There are many good books, excellent books available in the market, so you can go through many other books also. As I have heavily gained by reading this book, so I recommend this book, but it is not that there is no other book. There are many good books available in this domain. So thank you all. I appreciate your patience.